Hi everyone, I'm Avinav Mishra, roll number 2024022. Our project number is 138 and our project is titled Just Analytics, a database-driven player and match management system. So this is the business requirement of our project. First of all, let's see the problem statement. So as you all know, in the modern world, Just generates a large amount of data including player profiles, rating across different formats, match results, tournament information, etc. And managing all this data using unstructured methods can lead to data redundancy, data inconsistency, and difficulty in data retrieval. To fix all these issues, we have implemented a centralized and well-designed database system that can efficiently store, manage, and retrieve chess player data effectively. So this is the objective of our project, and this is the scope of our project, which lists some of the functionalities that we have implemented. This is the target user base of our project. We have also made some assumptions. Like first of all, we have assumed that the players have unique IDs. Every match comes under a tournament, and every match involves registered players only. Uh, so why are we using a database? Because database reduces data redundancy through normalization. It helps maintaining data integrity and data consistency, and the queries part helps in with data retrieval and analysis. So moving on to the ER diagram of our project. So this is the ER diagram of our project. As you can clearly see the four entities that we have used: player, rating, match, and tournament. You can also clearly see the different attributes, and the underlying attributes are the primary keys, which is player ID in player, rating ID in rating, match ID in match, and tournament ID in tournament. You can also clearly see the relations between them as well. First relation is has, which is one to many, because a single player can have multiple rating because of the different formats like classical, rapid, and blitz. Second relation is place, which is between player and match, and we have divided this relation into two because a player can play as white and black. This relation is one to many because a single player can play many matches. Third relation is host, which is between tournament and match, and this is one to many because a single tournament can host many matches. You can also clearly see that we have used double lines for total participation. There cannot be any player with no ratings, and there cannot be any match which is not being played by players, and there cannot be any match that is not being hosted by a tournament. So moving on to the relational schema of our project. So this is the relational schema of our project. As you can clearly see, the four entities that we have implemented in our ER diagram: player, tournament, match, and rating. You can also clearly see the primary keys mentioned as PKs and the foreign keys mentioned as FKs. So the player table and the rating table are joined using the player ID foreign key in rating and the player ID primary key in player. Also, match and tournament are joined using tournament ID foreign key in match and tournament ID primary key in tournament. Also, match and player table are joined using white player ID and black player ID foreign key in match and player ID in player. So this is all about the relational schema of our project. So this is the database schema of our project in MySQL workbench. As you can clearly see the different tables we have created: player, tournament, rating, and match. And you can also see all of their attributes with their proper key constraints. As you can clearly see, the player ID should be the primary key of the player table, and it is appended using the primary key constraint. Similarly, in tournament, the tournament ID, primary key constraint, rating ID in rating table, primary key constraint, and match ID in match table using the primary key constraint. We have also used the foreign key constraint to join the different tables. And we have also used some check constraint and unique constraint for some attributes as well. So this is the example data that we have used to populate our database. And this is the indexes we have created. So let me show you by using a simple query what our database looks like currently. So these are our players. These are the two tournaments. These are the rating of the players. And these are the matches that have so far been conducted in the tournaments. Thank you so much.
Hi, my name is Hariom Tiwari, roll number 2022194 of group 138, and now I am going to present task 4, 5 and 6 of our DBMS project. So here I have written 15 queries of varying complexity. Let's start with the basic query where we have selected the name and country of the table player where title is equals to GM. So let me run this query and you will see two columns, name and country. Alright. Now let's move to the join query. So see, here we are selecting P1 name, okay? P2 name, match date and result from match M. And this query demonstrates that the use of join operation. Since player data is stored separately, we join the player table twice to retrieve the names of both white and black players. So let me run the query and show you the output. So yeah, see, here we got the following columns which I mentioned earlier. And this avoids redundancy and follows normalization principles, while still allowing us to display meaningful match details. So here we basically avoid the redundancy. And now let's move to aggregation query. Here we are selecting name and we are just outputting the count M match ID. So we are outputting two columns here. Okay. And here we are using aggregation with count and group by to calculate the total number of matches in each tournament. So let me run this query and show you the output. See, here we got the name and total matches. So here we are using left join just to ensure that tournaments with no matches are also included, which improves completeness of the analysis. This is an advanced query using a common table expression and nested subqueries. First, we extract the latest classical rating for each player. Here we are extracting for the each player. And then from these latest ratings, we find the player with the highest rating. See here. From that thing, we are now finding the players who have the highest rating. This demonstrates multi-level querying and dynamic filtering based on derived data. So now let me run this query and show you how it works. See, name and rating. In addition to this, we have also implemented queries for updates, deletion, nested filtering, match statistics to fully support application requirements. Overall, our queries cover basic retrieval, joins, aggregation, and advanced nested logics. In task 5, we developed a Python-based application that interacts with our MySQL database along with triggers. So let me run the code. And here you can see the menu based system. But before showing anything here, let me explain you the triggers first, then I will show both the things together. And let me clarify you one thing that I have made the GUI in part 6, so I will explain that in part 6. So now let's go to triggers. So yeah, here I have added two triggers. The first trigger is that if you want to win the match or record the match, then the moves count must be greater than 0. And the second trigger is that if you want to add rating, then your rating should be in between 3000 and 0. Okay. So now let me now again go to VS Code and let me show you how it works. So when I'm going to view matches, second, so see, these are the matches we have, like 1, 2, 3, 4, 5 matches. And if I want to record a match, then I will write here 1. Okay, and it is asking me fight player ID. So basically we have 4 players, and so I am giving ID 2. Enter black player ID, I am giving 4. And it is asking enter tournament ID, like we have the 3 tournaments with IDs 1, 2 and 4, so I am giving 1. Okay, it is asking me the result that give us the result. So here I will type 1 0 1 0. Okay, it is asking moves count. See, here I have added a trigger that our moves count should not be less than 0. So let me show you, let me give it -5. See, it will give the error. See, error. Now I'm again adding the match. I'm recording the match again. I'm giving white player ID as 2 and black player ID as 4. And it is asking me the tournament ID 1. And then I'm giving the result as 0 1. And then it is asking me the moves count. So I will give it 256 because our moves count should always be greater than equal to 0. So this is the trigger. Now see, match recorded successfully. And if you want to view that match, then I will go to 2 and see. Here our match is being successfully recorded. Yeah, now I have these total 6 matches. Now if I want to exit from this menu, then I will press 6 and hit enter. See, connection closed. Alright, so in part 6 of our project, I made the GUI in Python using the Flask. So let me run my code. And here I will get the port. So I will just control and click it. And you can see the GUI. Like here I can add the match, I can add the rating, I can add the tournament, and here I can update the transaction, update the any value. If I click on commit, it will be permanently changed in the original DB database, or if I click rollback, it will not changed. And if I want to view my player table, then I click on players. You can see the player details of all the players. And if I want to see the matches, so I will just click here on the matches. You can see there are 1 2 3 4 5 matches. Okay, now if I want to add a match, so let me show you. White player ID, I'm giving it as 1. Black player ID, I'm giving it as 3. Tournament ID, I'm giving it as 2. And I'm giving the result as 0 1. And I'm giving the moves count as 369. And when I clicking and when I will click add match, see, this match is being added 14 1 3 2 0 1 369, the moves count which we gave, and this is the today's date 18th April 2026. If I want to go back, I can go back. Okay, and now let me show you the transaction on Workbench. So let me first show you the match table before starting a transaction. So here you can see that the row whose match ID is 2, the value of moves count is 50, right? Now in transaction A, if I want to update the 50 to 62, if I want to update it to 62, okay? And if I run it, but I have not committed yet, right? So when I try to access the match, I mean when I try to read the value, then here you will get the 62. But when another user try to read that value, like let me show you here. This is another user. Then see here old value, here it is still giving the old value. So basically this is the read write conflict. Like when someone wants to read and someone is reading at that time, so it will give the false value. So this is the read write conflict. And if I go to my transaction A, and if I commit it, let me commit it, okay, then this value 62 will be permanently reflected in the database. And if any user, like this is our user 2, wants to access the value, then he will get the 62. See, this is the 62. Why? Because we have permanently changed, we have committed the value in the database. Now let me explain you the write conflict. Let's go to database 1, and now we know that the value is 62, but here I want to update it again to 50, right? And I have run this script. Now, if another user wants to update the value to 80, okay, let me run it. Then what will happen? It will not be updated. Why? Because see, it is still in process. You can see the sign which is rotating. So it is still in the process. And as soon as I will commit the transaction A or rollback, okay, let me commit it. So what will happen? See, this one is committed, and now let's go to this one and see our transaction is completed, and it took 21 second. I mean, it waited for 21 second and then it updated the value. So now if I want to read the value from here, so see, it is 80. So it first waited for transaction A to be completed, and when transaction A was completed, then transaction B completed. So this was the transaction and GUI of our project. All right, so this complete all 6 tasks of our DBMS project covering database design, queries, application development, triggers, and transactions. Through this project, we ensured data integrity, consistency, and efficiency data management. Thank you.